Let us discuss this question. The question is, a wedge of mass capital M is equal to 4m for small m lies on a frictionless plane. A particle of mass small m approaches the wedge with speed v. There is no friction between the particle and the plane or between the particle and the wedge. The maximum height climbed by the particle on the wedge is given by. So to understand, they have to just note down the given data and try to recollect back what concepts we can apply here. Okay. So here, what is given here is, it is given that mass of wedge capital M is equal to 4 times small m, and mass of particle is, it is also given that mass of particle is equal to small m, and it is also given that a particle of mass small m approaches the wedge with the speed of the speed of v. So speed of particle is equal to v. Okay, and so to understand this, let us draw a pictorial representation of the given scenario. So let us say this is a wedge. This is a wedge, and let us say it is on a horizontal surface. It is on a horizontal surface. Okay, right. Now let's say a particle means, you can say here for understanding purpose it is a block, something kind of. Okay, is having mass m, moving with velocity v. Okay, it is moving with velocity v means it is having some kinetic energy and also having some momentum. Now initially the wedge is at rest. Okay, the wedge is initially it is at rest. Okay, now only particle is moving, right? Once the particle comes here, then it starts to raising up along the surface, along the inclined surface. Now let us say the next case, this is the horizontal surface, this is the wedge, Once the particle approaches here, so it raises to, let us say it is raising up to here, somewhere here. So let us say that is to height some h. After raising to some maximum height, then of course you can say whatever the kinetic energy it was having, it will convert to the potential energy, right? After raising to height h. Got it? Now what happens is, because there is no friction, mu is 0 between the wedge and surface, the moment the particle tries to climb it, whatever the kinetic energy it is having, it tries to transfers to this. Okay, now the wedge and particle together starts moving. So let us say both starts moving with a velocity of center of mass. Let us say this is velocity of center of mass of the wedge. Together they are moving with velocity v. So this is m, and mass of the wedge capital M is equal to 4 times small m. So to understand the scenario, let us use two steps here. The first step one is from law of conservation of momentum. Total initial momentum is equal to total final momentum. So initially the wedge is at rest, only particle is moving. So small m into v plus capital M into 0. So that gives you mv is equal to, finally, when the particle raises climbing this wedge, so when it has climbed to a height h, because the entire kinetic energy will be transferred to this potential energy. So and hence now both of these particle and wedge together are moving with a common velocity, let us say. That means small m plus 4m. This is capital M is nothing but 4m, right? 4m. Okay, together moving with the velocity of, let us say, vc. We don't know what is that. So from this we can write vc is equal to actually this is small m into initial velocity. You can write it as v by m plus 4m is 5m. So mm cancel, it becomes v by 5. You just keep this aside. Now, okay, you can take it as equation 1 also. Now, as what you are supposed to find, what is the height raised by the particle. So once that is complete kinetic energy is transferred to this, what you can say is according to work energy theorem, the initial kinetic energy is equal to, okay, you can say the change in kinetic energy of the system. So now you can write here, that is one thing. The other thing is total initial energy is equal to total final energy also, according to work energy theorem. Now here you can say that as by using conservation of mechanical energy or applying work energy theorem, as I said, you can see here that is step 2. By applying law of conservation of energy. Law of conservation of energy, LCE stands for law of conservation of energy, or work energy theorem. Work energy theorem, what we say is, initially the entire system is having kinetic energy, that is only charge is at rest, half mv square is equal to, now both verge plus particle together are moving with the velocity of center of mass, that is but they are having kinetic energy of small m. Capital M is nothing but 4m. They are moving with velocity of center of mass. Or here you can initially capital E are moving with velocity of center of mass. So this is the kinetic energy of the combined system. And because the small particle has raised to height h, a part is converted to mechanical, potential energy also. So it possesses mgh. Now on simplification.